Chapter 6, Discrete Probability Distributions. This is a small summary of what we have to cover for this chapter. So a random variable represents a numerical value associated with each outcome of a probability distribution. We use the letter X for a random variable, and then we have two examples: number of sales calls a salesperson makes in a day, time spent on sales calls in one day. We talked about on the previous chapter, the random variable could be discrete or could be continuous. Discrete is how many. That means has a finite or countable number of possible outcomes, something that you are able to count. While continuous could be any value in an interval or collection of intervals, how much we use for continuous. So example number 1, the number of stocks. Number of stocks is how many stocks. So this is going to be discrete random variable. We are able to count the number of stocks. Example number 2, the volume of water. So the amount of water can be any volume from 0 to 32 ounces, any number. So this is a continuous random variable. For the discrete probability distribution, two rules must apply. F of x has to be between 0 and 1 inclusive. That means every probability has to be between 0 and 1, and the summation of all the probabilities has to be equal to 1. So for this example, we have to check if all the probabilities are between 0 and 1, and this is true. All of them are between 0 and 1, and then we take the summation. If you take the summation, this is 0.64, 0.86, 0.96, 0.991. So both conditions apply. So this is a probability distribution. For the expected value or the mean, how we're supposed to calculate it? We multiply every x with the probability, and then the products are added. So the formula is summation of x times f of x. This is known as the mean or the expected value. Example number 1, the unit sold, this is your x. In this case we don't have the probability, but we have the frequency, number of days. So we have to figure out the relative frequency or probability. So for the relative frequency is 20 over 200, 0.1, 40 over 200, 0.2, and so on. So this is your x, this is your f of x. So we have to create a third column where we multiply the x with the f of x, and then we take the summation. So in this case, as you can see, we have the x, we have the f of x, we multiply 0 times 0.1, 0, 1 times 0.2, 0.2, and so on. So the summation is equal to 2. That means we expect to sell 2 TV sets per day. And this is a second example with the number of DVDs that someone may rent from a video store. So again, we have the x, we have the p of x, we multiply the two columns, and then the summation is equal almost to 1.5. So on average we rent 1.5, 1.49 DVDs for every single visit. For the variance, this is the formula. The variance is summation of x minus mu square times f of x. The standard deviation is very easy to calculate it, because simply you take the square root of the variance, and this is the standard deviation. However, for the variance we have to calculate x minus mu square first, and then we multiply with the f of x. The mu is the mean that we calculated before, the expected value. So let's go to see the same example. So I'm gonna continue with this example. This is the x and this is the f of x, and keep in mind that the mean is equal to 2. So what we do, we calculate x minus mu square. Actually, if you want the second column you can skip it, but anyway, 0 minus 2 is negative 2, 1 minus 2, and one more time the mean is 2, negative 1, 2 minus 2 is 0, 3 minus 2, 1, 4 minus 2, 2. And then we take the square of these numbers. So 4, 1, 0, 1, 4. Then we have the f of x from the problem, and you can go back 3 slides. And then what we do, simply we multiply x minus mu squared times f of x. I can show you by using the calculator in this case. So you can multiply 4 times 0.1, so 4 times 0.1, so this is the 0.4, 1 times 0.2, 0.2, and then you continue. So then you take the summation of 4 plus 0.2, 0.4 plus 0.2 plus 0 plus 0.2 plus 0.4. So we have 0.4 plus 0.2 plus 0 plus 0.2 plus 0.4. So this is the variance 1.2. And for the standard deviation you go to second x squared of 1.2, close the parenthesis, enter, and this is the standard deviation 1.095. And this is how we calculate the expected value and the variance. For the binomial distribution, these are the properties. We have two possible outcomes: success, letter S, and failure. So we have the probability of success that is going to be given, and also we have the random variable x that counts the number of successful trials. So for every problem we need the n. N is the sample size, p is the probability of success, q we don't need it because we will use the graphing calculator, but q is 1 minus p. If p is 0.4, q is 0.6. If p is 0.7, q is 0.3, the complement. And x is the number of successes in n trials. So in every problem you are looking for the n, the sample size for p, and for x. These are the three quantities that we have to find in every problem that we use the binomial distribution. I have here some phrases and math symbols, how to translate a word problem to a math symbol. So if you have the word at least means greater or equal than, more than, more without the equal sign, less than, less, no equal sign, no more than, the most, less than or equal to, you have to include the equal sign. And if you have exactly, equal is, this is exactly equal to a number. This is the binomial distribution formula, but we are not going to use it since we will use the graphing calculator. I have the whole formula here, but I will explain you how to use the graphing calculator. These are the steps for the graphing calculator. So you have to go to second variables, you have to go to letter 0 or A, depends if you have TI-83 or TI-84, but you have to go to binomial PDF, binomial probability density function, and go to enter. And then the correct order will be n, p, x. N, the sample size, the probability of success, and the number of successes in n trials. Let's go to see this example by using the graphing calculator. So in this case the probability of success is 0.75, so it's 75%. The sample size is 3, we have 3 patients. So find the probability that the surgery will be successful on exactly 2 patients. So we have the probability of success 0.75, n is equal to 3, x is equal to 2. So we have to go to binomial PDF, n, 3, p, 0.75, x, 2. And this is going to be the probability. So let's go to use now the graphing calculator. So you have to go to second, variables, and then this is a TI-83 that I have, you go to 0. But if you have TI-84, you have to go to letter A. Alright, so for now we go to 0, binomial PDF. Click enter. The next step is 3, 0.75, 2. Close the parenthesis, enter, and this is going to be the probability. If you want, I can go to 3 decimals. So you go to mode, go to float, to the next one, and go to 3 or 4 decimals. So I can go back, second, variables, I go to 0, and then 3, 0.75, 2. Close the parenthesis. So exactly the same number. Let's go to see the second example. For the second example, the probability of success is 0.41, the sample size is 4, and the problem says find the probability that at least 2. At least 2 means what? Greater or equal than 2. So greater or equal than 2 means 2, 3 and 4, and we have to stop at 4. Why? Because 4 is the sample size. So n is 4, p is 0.41, x is at least 2 or more. So we have to use the formula 3 times, 1 for 2, 1 for 3 and 1 for 4. So binomial PDF 4, 0.41, 2, and then we continue and we add the 3 probabilities. Let's do it by using again the graphing calculator. I go to clear, so second, variables, I go to 0, enter, 4, 0.41, 2, close the parenthesis, plus, same step, second, variables, binomial PDF, 4, 0.41, 3, close the parenthesis, plus second, variables, again I go to 0, in this case we have 4, 0.41, 4, close the parenthesis and then click enter, and this is the same probability, 0.542, the same that I have on example 2. Example 3, n is equal to 3 because we have 3 employees, the probability is 0.1, 10%, x is equal to 1. So we have to use the formula once, and then this is going to be the probability, 0.243. I want in this point to be able to use the graphing calculator, so you can give a shot and use your own calculator to figure out the probability. Now, the mean, the variance, and the standard deviation of the binomial distribution. The mean is n times p, n is the sample size, p is the probability of success. For the variance is n times p times q, and I repeat, q is 1 minus p. And then finally the standard deviation is the square root of the variance. So let's go to see this example, and again I will click clear. In this case the sample size is 30 because we have 30 days in June. The probability of a rain is 0.56, so Q, the complement, is 1 minus 0.56, which is 0.44. So for the mean is what? It's 30 times 0.56, so 16.8. That means you expect on average to rain almost 17 days in June in Pennsylvania, in Pittsburgh. Then for the variance we have the 30, the sample size, times 0.56 times, you can use a parenthesis, 1 minus 0.56 and close the parenthesis, or you can use directly the Q. Q is 1 minus P. Click enter. So 7.392 is the variance, and then you take the square root, so second x squared for the square root of 7.392, close the parenthesis, and this is the standard deviation.